So I'm a former pen tester, and I got tired of always fixing stuff or recommending stuff that is not always implementable. So went into Pvotal Technologies in order to prove that we could implement the stuff that we're talking about in pure infrastructure as code, and where security and speed go all the way around. I mean, always come hand to hand together. We use in front end Flutter, Dart mostly, cross-platform, using gRPC-web and gRPC. In the CI, Concourse, and Bash with our custom pipelines and custom manifest in order to have infrastructure as code. In continuous deployment, mostly Google PubSub to pass in between network layers so that there's no shared network or shared IPs between the different environments. We use Terraform for critical infrastructure deployments, and Argo CD, Argo Workflow, and the Argo Stack for deployment of the images. For infrastructure orchestration, we're heavily leveraging Terraform Cloud, and we're going to go into Terraform Cloud on-premise. We think that it's critical for large companies to work in IAC in that fashion. If you try to use Terraform with a bucket, you're going to encounter a lot of issues. And we're using HashiCorp Vault. It's the only thing that is not in GKE for us, outside Cloud SQL and Redis. And for the backend, we use Istio, we use MTLS. We started using Evenstore and got some issues with the front-end synchronization. And we're keeping it on the stove for now. And we're using most GCP native services for everything that needs to be used, because we think that going completely cross-cloud is an illusion, and you're better off using the native tools of the platforms to simplify and create a cross-abstraction layer on top. So we're going to talk now about a bit more complex stuff. So this is the architecture that we didn't pick. We're using REST with a mobile or a phone, interacting with a Google load balancer, using an HTTP2 neg with ambassador or emissary ingress, going to Ory Oathkeeper with a master CRD. And from that, it would route to GraphQL, and GraphQL would use the UUIDs of the resources and the queries and the mutations in order to obtain the information from the different domains. So we didn't want to do that for one very good specific reason. We didn't want the authorization control to be at the GraphQL layer. So if the GraphQL got owned, everything would be queryable directly from the GraphQL. I think that's an inherent issue, and we didn't want to use that for that reason. It's a control access point, and we think it's dangerous. So instead, we went with this architecture. So we're using gRPC-web and gRPC over HTTP3 for gRPC-web and HTTP2 for gRPC to the Google load balancer, and then container negs or a container network endpoint group to Ambassador, who has a gRPC-web to gRPC translation layer, for sending to Ory Oathkeeper for the coarse grain, so GWT validation, and then sends it to the gRPC microservice. The gRPC microservice has an interceptor validating and making the queries to our internal authorizer to expand the rules in the Zanzibar rule fashion, and checks with Keto the different rules assigned to the different people. So basically, Google load balancer, emissary ingress, Oathkeeper. If a GWT validates from Hydra, forwards it to the microservice does the deserialization. Initially, we wanted to put the Keto here and the deserialization here, but the issue is in gRPC, Keto, in here, they wouldn't have the protos in order to efficiently deserialize. And secondly, you would need to define a specific number of bytes to send in the header to Oathkeeper, because by default, it doesn't send the data. And your authorization and your objects are in the proto, which are in the body of a request. It would be complicated to integrate it all here, whereas here it's easier to decentralize it and have the different protos known only at those specific layers. So we integrated them specifically on the specific interceptors to have still like kind of an architecture validation instead of applicative. So getting a bit into more detail so you guys know what gRPC is and have a bit of context, it would be crude to not, for those of you guys who haven't been interacting in gRPC, to have a bit of context. So we're going to take a simple microchip service that has 4 types of strings, and then is a simple unary, as you see here, of a proto. In gRPC, you can have client-side unary, so one and have a response that is unary, or you can have a stream client and a server stream only, or you can have full bidirectional on both. Most of our examples are unary, so unary in that sense from client and unary from gRPC server, because when you do server stream, you're actually binding to one specific microservice instance, and you should only be using that for notification if you can, because otherwise it complexifies your deployment. You have your microchip, you have your RPC here. We have a custom authorization subscription reference. We're using Keto for subscription and information as well, and the different authorization scopes used by deployments. And we have a simple message that uses pagination and a specific response that are the different types of microchip brands and token for pagination. This specifically is what is used, for example, at the gRPC microservice layer. So Oathkeeper, in our case, we use Kratos and Hydra. Kratos, we don't use the standard front end. We built our own login with it. We might talk about at some point about open sourcing it, but we thought that Node.js was not secure enough. And so we built our login from Go templates purely. Initially, it was in pure Flutter, but we encountered some issues with front-end posts. So we ended up redoing it in Go templates. And so we have like another cluster that would be on top here, and the other cluster does contain Kratos and Hydra isolated from the applicative cluster. And we're using, for example, for now, RS-256, we're using an internal Hydra reference, the required scope the same as before, with a target audience and trusted issuers for our specific use case, and the method and the Oathkeeper reference for the URL. So basically, we register the authorizer on the microservice before it gets processed. So we ensure that the interceptor processes the request even before anything gets to the actual microservices. We enforce that in our DevOps layers, so it's not completely under the source code of the applicative developers. We're not that many, we're just 22, but we want to have a structure that allows us to have way more people. And so we use, this is the interceptor in the Go config, so we're importing the internal authorization reference and the profile PBs that are internally compiled. We use tons of internally compiled versions so that developers don't need to worry too much about PB or different elements of compilation in the CI. And we have an example here of a simple interceptor, for example, microchip service interceptor that is present on top of the others. We're using open tracing and open logging to have information about those interceptors and to have in order to ensure that they don't take too much time, but for now they are being stacked, so it's one after the other. So that is not super efficient for now. It takes like 0.02 milliseconds per interceptor. We're going to try to improve on that afterwards. What is Zanzibar? So the rules that you saw before that are here essentially allows you to define, for example, if somebody is an admin and he's trying to read, it would use the privileged microchip viewer to check if that is present in order to allow the call to go through when it's talking to the authorization service. And it would check, oh, is it a microchip editor? Not directly. Is it, well, yeah, in this case, yes, it is a microchip editor, because the microchip editor specifies the compute user set admin and your user doing the query is an admin. So it allows you to basically define privileges or specific privileges from a role that would be in Keto. So the role is in Keto, and the internal authorization service does the expansion for the service to check in terms of list and in terms of check. So in our config map of internal authorization service, it expands all of this. So if we decide to change it or change internal permissions, it would keep the, for example, admin role into Keto, but everything else is modified on the fly. So we don't need to constantly do migration in Keto for the tuples, but instead just change the configuration at the internal authorization service layer. And that prevents us from storing tons and tons of rules into Keto because they're deduced directly at the internal authorization service. So that's why we're having this talk is performance and number of rules is critical once you start doing that on every single query. So on every single query reaching our services, we perform that check. We don't have a Redis or caching yet, but we're planning to implement it if we start to see issues. But right now, the performance is good enough. It's taking 25 to 55 milliseconds in order to do that validation on every single query. When we talk now a bit more in depth for those that didn't understand, so before we're talking about why we have those rules, now we're talking what did we implement compared to the spec. The spec uses tuples. I'm not sure if you guys have heard about it, but tuples is what allows you to define permissions from one user to another, and a permission or a role that applies from that user. And so people reading after it could read the text, but in practice, there's the this that indicates that this is the compute user set and tuple being, well, not compute tuple, but compute user set being used. We implemented this compute user set. We're planning to implement tuple to user set, but we don't have the need yet for it. The union, and we're planning to implement intersection. We haven't seen a lot of use case for exclusion yet. So this is what allows us to have extension of the rules, and in order not to implement or put all the rules into Keto and complexifying our migrations in case we need to perform migrations. What are we trying to achieve with that? Well, in our specific use cases, because we have tons of roles of people in the horse domain, and you have medical data, you have sensitive data, and there's tons of roles that people need to allocate, and owners need to assign those roles to other people, and we want to granularly determine in the future that we have like a trainee of a groomer or a trainee of veterinarian being added, and they would have automatically all the required privileges on your data if you do choose to reference it for that person. And so we're using directly protobuf information in order to specify those elements. Right now we have not put general viewer, but it would be somewhere in the proto options. We would reference the I guess I could improve and add those references in the protobuf. We put it directly here, and our protobufs are used for Oathkeeper, for the authorization, for the front end, for the back end. Everything is determined from the proto reference. And so we think that it's quite a bit better than just open API. We use directly the proto spec to do everything. We're working right now on gRPC streams, and there are some issues with it. There are some advantages with it, but we're going to talk about it just in the next few slides. The time needed to perform the specific requests using gRPC-web over HTTP3. Here are all the options calls. And we use, well, all the options are performed, and then right after we have the actual backend queries that are done on the 14, and they're all done in parallel. We're using Flutter with a BloC pattern in order to have that level of performance, so that the entire subpage, once you click on it, loads in 250 to 350 milliseconds, depending on how close they are to the data center. So if they're really close, you can go down to 200 milliseconds, and we could eventually even use gRPC streams that we're planning to use to be fully event-driven, but we're having some slight issues with that, because you need to reference we need to reference event IDs so that if somebody edits something, he gets certification that somebody else edited the exact same stream. So having the privilege to do the edit is not enough. You need to provide references to other users in case that person edited. So we're working on that part so that the entire platform becomes a bit editable, like Google Docs or other Google products, for which you receive the server stream in order to inform you that something was edited live before, and you need the mechanism in order to synchronize and essentially solve conflicts. And we're working on that part. We did the backend part with EventStoreDB, but now we're doing the front-end part. The real critical part of our what we've added are mainly on here, on the internal authorization service. We've added those in order to minimize the number of rules in Keto. Of course, we're interacting in gRPC as well with Keto. And we think that the performance is critical in terms of number of rules. So that's why we thought for maintenance and long-term security that we needed to implement the Zanzibar spec because it was not good enough to have all the tuples being put into Keto, because if we decided to change the tuples, we would need tons and tons of migrations, and the migrations would need to have made, if we were implementing privileges and not only roles or top-level roles, we would have cascading modifications that were probably going to be needed, and this becomes rapidly very hard to manage. And so we thought before we go into large-scale production, we needed to implement the rest of the Zanzibar spec on the authorization layer. This end objective of what we're doing here is we want to have eventually the capability to handle offline traffic. So when the client will go completely offline, our blocks will be aware that the data is offline. We'll store part of the data locally if it can locally encrypt it using Flutter. Not Flutter for web, but Flutter for mobile, and use a secure local storage, because in the host domain or other domains, they often interact with mobile. And so we built that entire infrastructure to have low latency control over the entire front end, have client streams in the future in order to upload all the content to the backend, and have even synchronization as well during the control. And so that's the reason why we had to build on a lot of recent protocols in order to simplify client stream, in order to improve latency, in order to improve security, and to improve granular sharing between the different users of the platform. As you can see here as well, in terms of size, those are cores, so doesn't contain any data. And the different requests, because we're serializing in Proto, the times are fairly short, like 67 milliseconds, because in HTTP3, you gain up approximately 27% to 28% performance over HTTP2. And that can be enabled essentially in a few Terraform configs on Google load balancers, and it automatically handles it with a browser, and you don't have to worry about anything. For all intents and purposes, it's as if you're doing HTTP2. Google does all the heavy lifting. Advice for other people working in HTTP2 and HTTP3 gRPC-web: be careful about server streams and delays of reconnection. It rapidly becomes problematic because you're connecting to the exact same microservice in the backend. And we're advising people to be very familiar and work quite a bit on Unary. And also because there's a limit of 100 connections in your HTTP3 stream. And if you don't take care of that, the stream can become blocked. And until you start unallocating them, it will not transfer more data. So be careful about what you're doing in stream. If you don't know what you're doing, it takes quite a bit of SRE. And we've been working quite a bit on that part recently. And for that, there are multiple layers to be worrying about. There's the gRPC, there's a Google load balancer first, the client configuration. For us, it's Dart and Flutter. And then there's the emissary ingress layer from the Google load balancer to the emissary ingress, and then probably the authentication service with Oathkeeper to worry about, and then worry about the authorizer configuration and the interceptor configuration on server streams and how to handle it. So there are quite a few layers to handle. And for now, I think if you are using gRPC-web or gRPC with clients, you should mainly focus on Unary, get that done completely, and make sure that everything works for server streams, and then start using it. Client streams are not supported yet. So we're planning that only when it'll become supported, but we don't think that it will come through before another few years.
One question I have is, you're working essentially on this Keto for the last half a year or so. Is there anything you can give people in terms of guidance about the best way to get into it and how to evaluate it for usage in other projects?
So the first step is determining if you actually need it. So if you need to just manipulate a few tuples, and probably dynamic tuples with, let's say, organization references that can't be defined statically, I don't think that you can actually use Keto completely. the Zanzibar extension like we did completely for it, then you will probably, for example, probably Ory Cloud uses only direct tuples because organization references and those objects that are not static are much harder to express in Zanzibar rules. But if you need to have complex permissions related to multiple complex roles, then it becomes a different story. Then you probably need to implement both.
Okay, there was another question, just doesn't really have to do with Ory per se, but what's your experience with Terraform and how are you using the Ory stack with that?
Okay, so if we go back to the first one, we're using Terraform for absolutely everything. So Terraform,
I saw Pulumi mentioned as well.
No, we didn't go the Pulumi way because we think that Terraform, the main advantage of Terraform Cloud, allows you to work in parallel with a lot of people, because the Terraform on a bucket doesn't scale and is monolithic and causes issues. So we migrated from Terraform to Terraform Cloud, which is somewhat expensive if you go for a bit more use cases. And we're using it to deploy all our environments completely dynamically with just one service key of GCP. And it, from our Terraform configuration, creates absolutely everything else. So it creates the Cloud SQL, creates the Envoy configuration for the specific private network. So we don't use any public network. Everything is private. All the environments are isolated. And so we're using Terraform Cloud for that. And we think that it's a product that is not well known, but is very capable. It's an alternative to, I think, I've seen a few other implementations, but if you want to go full IAC, it is doable completely in IAC with Terraform Cloud. Argo workflow is very useful as well for those use cases. You would just need to use a cross-environment tool such as Google PubSub or others with Argo events in order to pass network boundaries.